he does this is saving you. Now stand up, be careful because it's going to be a big number. 1.5 kilowatts times about 15 cents. So $2 an hour he's saving you right
that's
now.
better. I never.
$2 an hour. It's not minimum wage, baby, but it's $2 an hour.
I don't sneeze at anything. Every bit helps.
$2 an hour.
Well, and then when the NOS was in New York, when I was in Europe, then there was nothing, no loads over there. So this was telling everything back to the grid.
And that's probably why your battery is getting pulled down. But I think your state of charge, there's something wrong with how it's calibrated. And I think it's because everything in here has been so unstable with this breaker tripping, with the loose wire on your load connection, that it's never really established a 0% state of charge. It's never really established a 100% state of charge. So what I'm hoping you're going to see, because of the tests that we did today and the evaluations that we did today, number one, I think you should be better able to balance your loads because you know what is red and you know what is
black, right?
Okay. Number two is we should not have the grid breaker failures anymore, right? And that was because of a loose connection on the grid breaker.
Yeah, right.
Okay. We do know that it's impossible to run your RV even in steady state with both ACs on, because if you have the hot plate and the two ACs by themselves are 3.5 kilowatts.
Right.
You could add a hot plate, which would take you to 4.5 kilowatts.
And
but
one
the very
more,
next
and the
thing
water
you do
heater
is going to trip it, and you can't control when the hot water heater comes on.
Correct.
So you don't have enough energy. Like you could draw 12 kilowatts with your RV, with everything that's in your load center, right? 240 volts at 50 amps, right? 12 kilowatts, 0.5 times 240. So what we want to do instead is manage the black leg, manage the red leg, so the sum total of those don't exceed the 5 kilowatt capacity of your inverter. We have a better chance of doing that now. Not worry anymore about the grid breaker tripping. Not worrying anymore about the generator starting, because you know you have to have the key in it and turned on.
Right.
And you can always test that by doing a forced start.
Yeah.
And you don't know if our parameters are wrong for the generator because we never had the key in it and turned on.
That's right.
We just don't know. So what you want to do is before the next scheduled start for the generator for 20 minutes, just come on out here
and
wait. See if it starts.
That's right.
Just make sure the key's on. What's left? Really, the only thing that you could do to improve the system would be to get soft starts on your ACs, at least one.
Yeah. And was the other thing that you mentioned, the auto, you said you wanted to even put it in this box.
The auto transformer. The auto transformer, if we do that, it's a big project because we've got to pull the inverter, rewire it, put the auto transformer underneath it. The output then to your RV goes through the auto transformer first. So what is the auto transformer doing? What you really are able to do is pull 2.5 kilowatts on either one of the two legs that you have. So the 120 volt leg, another 120 volt leg is your 240 volt service entrance to your RV. Each one of those could carry 2.5 kilowatts. We know that when both of your ACs are on, they're going to carry almost 3.5. Okay. Now there might have been some other small loads in there, like the lights, which are 0.5 kilowatt maybe or less.
And then the converter.
And the converter,
which was putting in 2.6 amps.
2.6 amps, something like that. But that's not very many kilowatts, right? 2.6 amps times 120 volts. Could be.
But it was on both legs.
Oh, it was on both legs, so it's 240 times. That.
3.6.
So you could, now we've got some data that you can start to crunch some numbers, and you can see that with the generator running, you can power both your ACs because it's got no problem handling the 3.5.
Right.
In fact, it was providing the 3.5 to the two ACs, and it was providing one to charge the batteries.
Right.
So it was providing 4.5. What we do have to worry about is there's a maximum pass-through energy on the AC bus. That's all these breakers are connected on the AC bus of 12 kilowatts. So the combination of generator or grid and battery through the inverter and solar can equal 12 kilowatts. And we were up around 11.4 when we had hot plates on, tea kettles on, lights on, converter on, ACs on, right?
Yep.
But we know it can do it. So whether or not you're on the generator running or whether you're on the grid running, you can pass through, we know, up to 11.5 kilowatts through the system.
So the advantage of the auto transformer would be nil at
The
this
auto,
point.
the auto, going back to the auto, yeah, I got off track. So going back to the auto transformer, what it's going to do is if you want to pull 3.5 on a leg that can only handle 2.5, and 1 on the other leg, the sum total would be 4.5. It's going to balance those two at 2.25 on each leg. So what the auto transformer basically does is take all the load you have on one leg, all the load you have on the other leg, and balance those two so that they're even.
Mm-hmm.
So the inverter will continue to operate without failure as long as the load doesn't exceed 5, and that 5 is the sum of the two. Without worrying about the
Which
threshold
one has
of
what?
2.5 on either.
Right, it balances them down.
That's it.
And so it works because you take the red and the black here and you put it into the auto transformer, and then there's another red and black that come out of it that goes.
So you take a 120 volt circuit, you bring it into the auto transformer. You take another 120 volt circuit and you bring it into the auto transformer. The auto transformer gives you a neutral that you don't have on an individual leg. It gives you a neutral. So this is a 240 volt inverter. It's a grid tied inverter. It has a neutral. So to give you a balanced legs going to your RV on the output side, because the input side is 240 split phase,
right.
120, 240. To give you that 120, 240, we have to form a neutral. That's what the auto transformer does.
Okay.
It gives us a neutral. And having that neutral allows those two legs to balance. Okay? In the absence of that, you just have two independent 120 volt circuits.
And that's what we have here?
That's what you have in the red and the black.
So,
yep.
But I'm not clear then. For the 240, one of these is carrying 120, the other's carrying 120.
Well, keep in mind 240 is just 240. So if you have a load that's just 240, the black wire and the red wire are wired into that. There is no neutral, it's just 240.
Okay.
Okay? That's not the problem.
So what happens when you're down at the 120 end here? Because it's still coming out of this. You're just splitting off one of them, is that right?
Well, the wires are only carrying 120 volts each.
Right.
So all your devices in the RV
Either have the black
120.
wire in a neutral or the red wire in the neutral, not both.
Yeah,
Okay.
that's exactly right. Okay. That's exactly right. And we need to get to the point where we've created split phase power with a neutral so that we can balance the two legs. And that's not happening right now. And I think we have space underneath here, but the reality is we have two 5 kilowatt batteries in here. This the enclosure was designed for 4, up to 4.
Right.
So we have 10 kilowatt hours here. The rule of thumb is a minimum battery energy storage you'd want to have is 2 times the kilowatt output of your inverter. 2 times. So we have it, 10 kilowatt hours.
Right, from a 5 kilowatt
5 kilowatt
inverter.
inverter, right? You would have more energy storage capacity if you had another battery. That would be 15 kilowatt hours. Batteries are expensive. Today, probably the least expensive LFP battery that you can get, and you'd want to use the same batteries here. These are marine grade waterproof batteries, is probably around $1,700, $1,800 before delivery.
Right.
So you could go online, find a high quality LFP battery. These particular batteries, I think, were about $1,800 each. So,
But they're parallel wired 48 volts.
correct.
So we could drop
and
another
we
one
would
in.
parallel another one. We could parallel another one. There's room. If we put the auto transformer in here, I'm hoping it's not any wider than a battery. So that means now you wouldn't have capacity for 20 kilowatt hours. You got 10. We're hoping you would have enough for 15 in the future, plus your auto transformer. So you get 50% more autonomy.
Yeah.
Energy storage, possibly, plus your auto transformer to balance your loads.
Right. Unless it's small enough and comes in a waterproof casing and could be put here.
You could put the auto transformer outside, but I prefer all your AC voltage to stay in the box. Because everything's bonded, everything's grounded, nothing is accessible to someone else.
Okay.
The auto transformer will not be a weatherproof box, so we'll end up having to put it in some kind of enclosure. So now we've got to have connectors, we've got to have
Right.
Right. entrances into each box.
Okay.
You know what? You end up spending a lot of money that would be better spent by just buying a good quality auto transformer, put it in a place where it's going to be safe, and get it underneath where it's not accessible. The auto transformer's not going to fail. I
But we'll
guarantee
probably
you
go-
the inverter's going to fail before
Right,
the
that's
auto
right.
transformer.
So we'll probably go soft start first, let
Yeah.
that work for a while, and then see if we need the.
The soft start,
Absolutely.
what's the end game in the soft start? The end game in the soft start is I want to be able to run at least an air conditioner without doing anything,
Right. That's right.
right? And I don't think you're ever going to be able to run 2 air conditioners and a bunch of loads.
No.
Unless you're either connected to the grid or you're connected to the generator.
Right.
Then you can.
Right.
If you're connected to the grid, you
But the
got
soft
power
start on
source.
one may give us the opportunity to run one. If there's a heat wave and the grid is down and there's no fossil fuels, just using our solar power, we could cool down the baby.
I think so.
Yeah. Okay.
Yeah, yeah.
I'm going to stop filming now and thank you. It's starting to rain.